I'm going to walk through the importance of p-values and how to calculate them in Excel, and start with this example of turbidity versus phosphorus. We looked at the qualitative value in time series and then looked at the quantitative value with this regression. Focusing in on the regression, we looked at this r-squared value as an indication of how well this line fits these points, or how tightly the points are clustered around the line. And we simply did that by displaying the r-squared value in this dialog box. And so that was readily calculated by Excel. Let's think about a hypothetical scenario where instead of going out monthly, we went out only twice, once in May and once in June. If we calculate the r-squared for only those 2 points, so we've taken just these 2 points out of this regression, we get an r-squared of 1. It's perfect. And so does that imply that we should only use these 2 points and throw out all those other data points? No, it doesn't, because while this says it's a perfect r-squared, it does not represent the full distribution of the population of points as well as this one does. And so the way that we assess that, or the significance of this r-squared, is through a p-value. We can calculate a p-value in Excel by going into Data and Data Analysis. This package, however, is not always installed automatically in versions of Excel. So if you don't see this Data Analysis tool pack option, then search on the internet and you can find instructions on Microsoft's website on how to load this analysis tool pack, and it is free. So then you can come in and select Data Analysis, use the dialog box to select Regression, and then come in to the Y input range and select, including the column headings, the phosphorus, and for the Y, the turbidity columns, and then say that you included the labels in there. And it's going to output this into a new worksheet. And so I can come in here and see here is the r-squared value from the chart, and then down here is the p-value. So we get a very small number for that p-value, which we can look at in another format by changing that to a number. We will have to add quite a few decimal places to that because it is such a small number, but we can view that in this more traditional way rather than scientific notation. So I'm going to copy that value and come back over here to the plot, and I'm going to just insert a text box here and add that p-value onto the chart for reference. Let's so we could try to do the same thing for this scenario with only 2 points, but with a sample size of 2, we actually can't even calculate a p-value. The sample size is too small, so we have to go to 3 sample points at least. So I'm going to move these over and do a third regression. Oh, my p-value got lost there. I'm going to move that back over. And for demonstration, I'm just going to copy this and go in and expand the selection and grab 3 points. So I'm going to include April in the regression. And now I have an r-squared of 0.94. So it's intermediate between this and then the perfect r-squared. And now let's go in and calculate the p-value for just those 3 points. And so I'm going to go in and select those 3 points for total phos for X and the 3 points for Y, and I don't have labels now. And then I come up over here and I get, I see the same r-squared value again that I got from the trend line, and a p-value of 0.15, so a much larger number. I'm going to copy that and paste it over here on the chart where I have only used 3 of the data points. And so again, that's including April. And So the R squared is the goodness of fit of the line for the points, or how close the points are to the line. So how well we might do at predicting this set of points with this line. And again, an R squared of 1 is perfect, and 0.94 over here is an intermediate value. But we have to look at the significance of that relationship. So again, we can't even calculate significance with only 2 points. With 3 points, the R squared is pretty good, but it's not significant. It's not a significant relationship. A typical threshold is 0.05 for a p-value, and basically the p-value is the likelihood of having these points come up with this relationship if there was no relationship. So you randomly grabbed 3 points and they happen to show this relationship. With as few as 3 points, there's a pretty good likelihood of that. With the larger number of points over here, with 12 sample points, we see that we have the relationship. The R squared's not quite as good because some of the points fall off of it, but the slope of this line is significant for explaining the relationship between turbidity and total phosphorus. This number is very small, so it's very unlikely that we would have gotten this distribution of points if there wasn't actually a relationship between them. And so 0.05 is a typical threshold, and we usually don't go any lower than 0.001. And so I'm going to change this to say the p-value is less than 0.001. And so this is a great p-value and a pretty good R squared. And so it's these two statistics that are important for evaluating the quality of a relationship like this. And so if we're thinking about trying to predict total phosphorus from something like turbidity, then we want to look at a plot like this.